Hello everyone, thank you very much for watching this video. I'm Mr. Matt and this is Dr. Tot. Dr. Tot's cookie for class. Very good. And welcome to SAT ACT Prep. This is quick drill set B to operations with numbers between 0 and 1. So as we've been discussing before, we can solve a lot of these problems conceptually by predicting what would occur if the value underwent the operation being greater than 1, or if the value were greater than 1 as compared to in between 0 and 1. If we understand what, or the relative magnitude of the outcome, what would actually happen to the value if it was a quote-unquote normal number being greater than 1, then we can reverse that outcome to understand what would happen if the number's between 0 and 1. So let's look at a few examples. I'm going to share my screen with you here. If you have any questions, please leave me a comment below. And if you find these videos helpful, then please like and subscribe and share with your friends. Thank you very much. And let's look at a few problems here. So this document is going to be available on Certified Learning Center's website. Just make sure that you're looking at the document with the reference number 1005-8. Both the Word and the PDF will be available using the links in the description below. Okay, I'll recommend that you pause this video after we read it aloud together. Pause the video after we read the question aloud together and attempt it yourself, and then unpause the video to watch the solution. So question number 1 asks, if A is greater than 0 and less than 1, which of the following is listed in ascending order? We have A to the 1/3, A to the 2/3, A to the 1/2, and A to the 3/2 powers. So take a few moments and solve that problem, please. So first of all, these fractions do not evaluate into exact decimals, meaning that they repeat, or half of them at least, repeat infinitely. 1/3 is 0.3 bar, and 2/3 is 0.6 bar, meaning that the 3 and the 6 will just keep repeating forever and ever. So they're not easy to work with fractions. So we might benefit here from some approximation rather than trying to evaluate these expressions directly. So let's first think about these. I'm going to put them in order. So we have A to the 1/3, A to the 1/2, A to the 2/3, and A to the 3/2. So that's listing the exponents from least to greatest. So what I'm going to approximate these as instead, as A to the 1/4, I can leave A to the 1/2 because that's just the square root of A. A to the 2/3, I'm going to think about that as just larger than A, so that's A to the 0.6 bar, right? So I'm going to think about that as maybe A to the 3/4 power. I'm not going to actually evaluate that, but you'll see what happens when we get to the chart. And A to the 3/2, that's about A to the 1.5 power. I'm just going to think about that as A squared instead. So now, if we draw out a conceptual chart and see what would happen if the number were greater than 1 as opposed to in between 0 and 1. So first, let's hypothesize if A were greater than 1. So if A is greater than 1, and we took the 1/4 power, the 1/4 power, which remember is the same thing as the 4th root. So A to the 1/4 power is the same thing as the 4th root of A. A to the 1/2 power is the same thing as the square root of A. So if we took the 4th root of A, we would expect that to go down from A. And we would expect it to go down from A to a greater extent than just taking the square root of A. So you see how A to the 3/4 is even greater than the square root of A, because the square root is 1/2, 0.5. So 0.6 is it's obviously a higher number than 0.5. So I can think about these with respect to their relationships to each other and hypothesize about or extrapolate to what would happen with this rather odd exponent of 3/4. So if I took the fourth root of a, I would expect it to go way down, even more so than the square root of a. So this guy is going to go down the least. The square root of a would go down more than that guy, and the fourth root of a would go down the most. A squared, however, would increase. So we can use the magnitude of the arrows, even though that a to the 3/4 power or a to the 0.6 power is a really weird exponent to think of or to try to mentally examine or compute. We can think about them in relationships to the other values that we do have predictive outcomes or can make predictive um, uh, hypothesis or extrapolations. We can understand the relationship between the fourth root and the square root better than we can understand something raised to the 3/4 power. So all of these relationships would be reversed. So this guy would actually be the greatest, followed by this guy, and then the last form of a to the 3/2 power would actually decrease. So if we're writing them in ascending order, we want to go least to greatest. So this is going to be a to the 3/2, followed by a to the 2/3, followed by a to the 1/2, and lastly, a to the 1/3 power. And that is going to be answer selection C. Question number 2 asks, if a is greater than 0 and less than 1, which of the following is listed in ascending order? We have a to the 5th power, we have a to the negative 3rd power, we have a to the negative 5th power, and we have a squared. So take a few moments and solve that problem, please. So we do have this problem with the odd values. Well, we would have a problem with odd values if these original value were negative, and we will see that in a few other problems. But here, the value that we're starting with a is in between 0 and 1, so it is positive. So you don't need to worry about the odd versus even exponentiations. Remember that if you take a negative number and raise it to an even power, it's going to turn into a positive number. But if you take a negative number and raise it to an odd power, it's going to remain negative. So that's what I'm talking about. Here, though, a is not negative. A is in between 0 and 1. It's just the exponent that's negative. So don't confuse that. That has a conversion that anything raised to, or I should say you can convert that easily, because anything raised to a negative exponent is just equal to 1 over that value raised to the positive version of its original exponent. So a to the negative m power is equal to 1 over a to that positive m power. So what we can do here is think about what would happen if the number were greater than 1 and just reverse those outcomes to understand what would happen if the number's in between 0 and 1. So let's rank or order these roughly. So I'm going to say a to the negative 5th, a to the negative 3rd, a squared, a to the 5th power. So if a were greater than 1, and we raised it to the negative 5th power, remember that's going to go under 1. So a to the negative 3rd power is going to decrease, but a to the negative 5th power is going to decrease even more. So the opposite is going to be true if a were in between 0 and 1. A to the negative 5th would be the greatest, followed by a to the negative 3rd, because they're actually going to increase, not decrease. If we have a value greater than 1 and we squared it, we would normally expect that value to increase. And if we raise that value to the 5th power, we would expect it to increase even more. So the opposite is true if that number is in between 0 and 1. So if we're placing these values in ascending order, we're going from the least, which is a to the 5th power, then a squared, then a to the negative third power, then a to the negative fifth power. And that's answer selection C. Question number 3 asks, if a is greater than 0 and less than 1, which of the following is listed in descending order? We have a to the 1/4 power, a to the 1/2 power, a to the 2/1 power, and a to the 3/1 power. So take a few moments and solve that problem, please. So if we just convert these into values or expressions that are a little bit easier to think about, let me just copy them down as they're written. A to the 1/4 power, that's the same thing as the fourth root of a. A to the 1/2 power is the same thing as the square root of a. Really, it's the fourth root of a to the 1 power, but because that numerator is 1, but anything raised to the 1 power is that same thing, so it doesn't have any effect, so we don't write it. But it would normally be have an exponent of 1, but that 1 just doesn't do anything, so we don't have to write it there. This is just a squared, right? Because 2 divided by 1 is still 2. The same thing here, this is just a to the third. So now if we examine as compared to a conventional number, quote unquote, greater than 1, so if a is greater than 1 versus if a is in between 0 and 1, if a is greater than 1 and we took the cube root, we would expect that to go way down as compared to the square root, but we would expect both of them to decrease. So those are going to be the opposite results as if a were in between 0 and 1. If a were greater than 1 and we square it, we would expect it to go up. If we cubed it, we would expect it to go up even more. So the opposite is going to be true if a is in between 0 and 1. So we're going in descending order now. So we're starting with the most, which is going to be the fourth root of a, which as they listed is the same thing as a to the 1/4 power, followed by a to the 1/2 power, followed by a to the 2/1 power, and then lastly followed by a to the 3/1 power. And that's going to be answer selection A. Question number 4 asks, if a is less than -1, which of the following is listed in ascending order? We have a to the 5th, a to the 6th, a to the 4th, a to the 7th. So take a few moments and solve that problem, please. So if we wanted to, we could use an actual value here. So the domain is less than -1, so we might pick -2 for a. And if that's the case, then we would have -2 to the 5th, we'd have -2 to the 6th, we'd have -2 to the 4th. Let me put that first, actually. -2 to the 4th, and -2 to the 7th. So remember, the odd exponentiations are going to retain the negativity, and the even exponentiations are going to turn positive. If the higher magnitude exponents are going to create higher magnitude outcomes, so they're going to be farther from 0. Anything raised to the 4th power is going to be smaller than something raised to the 5th power, but with that negative outcome that you have to consider, if the value is negative from the beginning and you raise it to an odd power, it's going to now have a larger magnitude, meaning that it's farther from 0 on the number line, but it's on the opposite side, on the negative side of the number line. So it's a smaller value, actually. So you have to, these are two competing characteristics that you need to keep in mind when solving these types of problems conceptually. If you had a calculator, you could evaluate these and just rank them in ascending order, and then you'd have your answer. If we're going to evaluate them conceptually, first I'm just going to acknowledge that this is going to have a positive outcome, this is going to have a negative outcome, this is going to have a positive outcome, and this is going to have a negative outcome, just purely from the even versus odd exponents. Now, if you raise it to a higher exponent, it's going to be a higher magnitude, but just watch out for negative numbers, because negative values with higher magnitudes are actually smaller numbers. Negative 100 is a smaller number than negative 1, right? It's better to owe somebody $1 than to owe them $100. So negative 2 to the fourth is going to be a positive small number relative to negative 2 to the sixth, because that's going to be a positive large number. So in other words, I'm going to give this guy, this is just another method that we can use to solve here conceptually. I'm going to give negative 2 to the sixth power 2 up arrows, and I'm going to give negative 2 to the fourth power 1 up arrow. Now this is where it's going to get tricky conceptually. Negative 2 to the fifth power, that's going to be a small outcome. It's going to have a small relative magnitude, but it's going to be negative. So it's actually going to be larger than the negative value that has a larger magnitude. It's like that negative 100 versus negative 1 situation. So negative 2 to the fifth power, that's going to be a smaller exponentiation, but because it's a smaller negative number, it's overall a larger value in the scheme of all of these values compared. So this is a, if you think about it as a large negative, or it's a larger number, but it's a small negative, so it means it's a larger number overall. So it's only going to get 1 down arrow. So this is, I know it's confusing, so you have to take time to understand that this is a small negative, so therefore overall it is larger than this large negative, because it overall is a smaller overall value, and respective to the other terms, it's the smallest value. So I will concede the fact that that is pretty tricky, and if you're ever in doubt, then you can just write out the actual exponentiations of negative 2 times negative 2 times negative 2 times negative 2 for negative 2 to the fourth power, for example, and actually do the computations. So here, if we're going in ascending order, we're going to start with the least. That's going to be negative 2 to the seventh power, followed by negative 2 to the fifth power, followed by negative 2 to the fourth power, and then lastly, the largest term is going to be negative 2 to the sixth power. And that's going to be answer selection D. Question number 5 asks, if a is less than negative 1, which of the following is listed in ascending order? We have a to the fifth power, we have a to the negative 2 power, we have a to the third power, and we have a to the negative 4 power. We'll take a few moments and solve that problem, please. So again, identifying the domain as less than negative 1, we can pick an easy to work with number, let's say negative 2. And so if we evaluate this, we have a to the fifth, we have a to the negative 2, we have a to the third, and we have a to the negative fourth. So substituting in negative 2 to the fifth power is going to be a negative 32. A to the negative 2 power, that's equal to 1 over a to the positive 2 power. That's going to be 1 over negative 2 squared. That's going to be 1/4. A cubed is going to be negative 2 to the third power. That's going to be a negative 8. And a to the negative 4 power, that's equal to 1 over a to the positive 4 power. So that's substituting in negative 2 for a. We're going to have 1 over negative 2 to the fourth power, which is going to be 1 over positive 16. So we have negative 32, positive 1/4, negative 8, positive 1/16. We're putting these in ascending order, so we need to go least to greatest. The least is going to be the largest negative value. That's represented, that's negative 32, which represents a to the fifth power, followed by negative 8, which is representing a to the third power. Then we're going to go to the smallest positive value, which is a to the negative fourth, excuse me, a to the negative 4 power. And then lastly, the largest value is going to be a to the negative 2 power. And that is going to be answer selection D. Last problem, number 6 asks, if a is less than negative 1, which of the following is listed in ascending order? We have a to the 2.6 power, we have a to the 1.2 power, we have a to the negative 1.5 power, and we have a to the negative 3.4 power. So take a few moments and solve that problem, please. So first of all, since we're dealing with rather irregular exponents, and we're just asked not to even evaluate for their exact numeric value, but to put them into relative rankings, we don't really need to know their exact value. And so to solve quickest, it might be easier to just approximate some other easier to work with exponents. So let's look at these individually. We have a to the 2.6, a to the 1.2 power, a to the negative 1.5 power, and a to the negative 3.4 power. So I'm going to round up. You can't, you want to avoid numbers that have their own special characteristics. Remember that 0, 1, and sometimes 2, but really 0 and 1 are unique values because of the inverse and identity properties of addition and multiplication. So they have unique characteristics. 0, for example, is the ultimate nullifier. If you multiply anything by 0 or any number of values by 0, the outcome is always 0. If you multiply anything by 1, you still have the same thing that you started with. Those are unique number properties that we've discussed already in previous videos. And so you want to avoid those values. You want to work with conventional values that are always going to operate in the same direction, even if they are at different scales. So for the second value of a to the 1.2 power, I want to avoid replacing that with a to the 1 power, because a to the first power is universal. That's never going to change, because anything to the first power is that same something. So I'm not capturing the actual operation of exponentiation when I pick that special number to work with. The same thing would be true with 0, because anything raised to the 0 power, that's a special number property. Anything raised to the 0 power is 1, and that's never going to change. So that won't be helpful in your approximations. So round up, in other words. I'm going to approximate a to the 2.6 to be about a to the raised to the third power. I'm going to approximate a to the 1.2 to be the same thing conceptually as a squared. I'm going to pick this guy to be a to the negative 2 power, and I'm going to pick this guy to be a to the negative 4 power. Now I can draw my table and compare it to more conventional numbers, namely numbers greater than 1. So if a were greater than 1, I'm going to examine that outcome and flip that outcome on its head when analyzing what would happen if the number's in between 0 and 1. So normally if a is greater than 1 and we cube it, we would expect it to go way up, especially in comparison to squaring it. We would expect both squaring and cubing to increase the value, but we would expect cubing to increase it to a greater extent. Therefore, the opposite outcome will occur if the number is in between 0 and 1. So I can reverse the direction of these arrows. If we have a number greater than 1 and we take it to the negative 2 power, we would expect that to decrease because it's going to go underneath of 1. It's going to turn into a fraction with a numerator of 1. So it's going to be less than 1. So it's definitely going to decrease. If we started out with a number greater than 1 and we ended up with a number less than 1, we definitely decreased. And if we take that value to the negative 4th power, we would expect it to decrease even more. So the opposite will be true if the number was in between 0 and 1. And we're trying to put these in ascending order. So we're going to go least to greatest. So that's going to be a to the 2.6 power, followed by a to the 1.2 power, followed by a to the negative 1.5 power, and lastly, the greatest will be a to the negative 3.4 power. and that's answer selection A. If you have any questions on anything that we've done in this video, then please let me know in the comments below. If you find these videos helpful, then please like, subscribe, and share with your friends. I appreciate you all very much. And otherwise, I hope you have a wonderful night. And Dr. Todd, you did a very good job. You want to get your paycheck? You guys say goodbye. Very good. You sit. You say bye. Say bye.